Good day, everybody. I'm with you to generalize a super popular math channel problem type. And let me just write down the form that this is in. It deals with an ilk of problems that involve de-nesting. Okay. And so notice we have a here, and notice that a squared would be 9. 9 minus 1 is 8. So you see, we can rewrite this in the more symbolic, abstract way, if you will. A squared minus 1. And the fact that these two objects are one apart, so to speak, I almost forgot a squared minus 1 right there, makes the algebra work out very nicely. Okay. Now I've done most of the work, so I won't say too much about it. All of this stuff is fairly obvious stuff here. We're assuming a would have to be greater than 1, greater than or equal to 1 for this to make any sense. And so even though this is the definition of absolute value, we can remove the absolute value bars. Okay. So now there's some things that are fairly, I hate to use the word obvious because that always insults somebody, including me, you know. But for this to work out nicely, we have to force it to equal to some object squared, so that when you take the square root of something squared, you get the something, right? Now, when you expand this out, you get this expression right here. Okay, and so it's very natural to make these assignments here. Okay, and part of it has to do with the fact that there's a 2 present right here, you know, but it does work out nicely because when you sum up x and y, you do get a, right? So that works out very nicely, and then when you, at this cross term here, it works out nicely as well. Okay, so and here's all the work right here, and you can see that it works out. Okay, now, so this assignment is correct. It's a plus 1 over 2 for x, and y is equal to a minus 1 over 2. And you can swap those around if you want to. It's symmetric. Okay, it's symmetric. Okay, so in this particular case, let's see, I wrote all this down. Yeah. All of this equals to what I just told you, right? Yep. This is your, this part would add up right here. Okay, this would be your x, your y, and then your 2 times xy right here. And you guys can multiply this out to see that you get the original radicand. Okay, if you multiply that out, you'll get this, and I'll leave that's easy. It's very straightforward. Okay, so anyway, for this particular problem, our a is certainly equal to 3. Okay, so for a equals 3, what would this be for our a? A is equal to 3. That would result in x is equal to, if a is equal to 3, then you get x is equal to 2. All right. And if a is equal to 3, you would get y is equal to 1. Okay, so you get x equal 2, y equals 1. Right? So the answer right here would just be, I'll just use this right here, it's convenient, the square root of 2 minus the square root of 1, which is just 1. Okay? And y'all, again, it's very easy when you square this, the square root of 2 minus 1, quantity squared, is certainly equal to 3 square root of 2, then 1 squared, that would be 3. All right. And then you have minus 2 times root 2 times 1. But notice if you bring the 2 inside of here, it becomes a 4. So this would be equal to 3 minus root 8. Okay? So you see, that's how we did it. This one turned out to be fairly easy as far as the numbers. But notice this seems to work for only integers, but it doesn't. It works for irrational numbers. So try it out for irrational numbers. I may do a video on rational numbers. Okay. But anyway, this is the answer to this special case work by this particular channel. They say it's a super interesting, and they categorize it as Japanese. I've seen this all over the place. Probably 200 channels have done this problem type. This is probably the smallest one that's You know, another example would be, say, the square root of 5 minus the square root of 24 would be another example of this problem type. And you can just go on and on. But almost everybody does integers. But you could also do this. You could do square root of 27 inside of here, right? Square root of 27 minus the square root of 26. See, that would be also. Nobody does these. I don't know if they're afraid of irrational numbers, but this would also work out nicely as well. Okay? See how that is? A square root of 27 squared is 27. 27 minus 1 is 26, but it's inside the radical from this structure over here. Okay? So this would be another one that is in this form, but just about everybody puts an integer right here. But anyway, hope you enjoyed the proof, and again, I hope I didn't leave out too much for you. This is very easy to verify that these are the correct assignments. You can check it, that it comes out equal to this again. So anyway, that is all. Thank you for viewing.